Hello. Okay. So yesterday we started with VPC. So what is VPC? VPC is a VPC is a custom network in cloud. Why we require VPC? To have a more control over our EC2 machines or any on a network level. By default, Amazon has provided a VPC called default VPC on which every subnet or everything is connected over internet, right? And we don't have any control, major control on the default VPC provided by Amazon. Okay, we have seen default VPC. Now we are creating custom VPC. Okay, to have more control over the network, right? We started with creating the VPC. We added subnet. What is subnet? Subnet is a small segment of the actual network. It contains small IP ranges of the whole network, and each subnet will be associated to a availability zone. So if you want to create multiple subnet in one availability zone, you can create. Okay, and but one subnet can be created in multiple availability zone. Okay, so one subnet, one availability zone. But inside a availability zone, you can create multiple subnets. So in a company, generally, in each availability zone, there are at least two subnets. So whenever we are creating a new VPC, by default, security group, NACL, and route table are created. Then we added two subnet with the IP range of 10.0.1.0/24 and another one 10.0.2.0/24. Then routed, we attached the internet gateway to our VPC, and we have created a new route table. We call it public route table, and we attach internet gateway to the new route table. Then we associated the public subnet to public route table. We didn't attach main route table to internet. Never attach main route table to internet. Why? Because whenever a new subnet is created, all these new subnet will be attached to the main route table by default, and we don't want any subnet to be exposed to internet. If you want, you should expose any subnet explicitly over the internet. By default, it should not be exposed to internet. Everything should be private, right? Till now we have created this. Then yesterday we created one EC2 machine in our public subnet, and we have created a security group with port SSH and HTTP and HTTPS port in our new VPC. So all the security groups we have to create again, because security group are VPC associated. After creating security group, we have launched the EC2 machine. And we connected to that particular EC2 machine. So you can see here, this is the public EC2 machine which yesterday we created, and you can check it is in our VPC, custom VPC, and it has a IP address, public IP address, and this is a private IP address. And if you go to the private EC2 machine, you can see you don't have any IP address. This is your private IP address. There is no public IP address. So can I connect to public EC2 machine? Yes, I can connect to public EC2 machine and just click on connect. But can I connect to private EC2 machine over the internet? Now you can see the instance you cannot connect to the private EC2 machine because it doesn't have internet access. Okay, so I have connected to public EC2 machine. This is my public EC2 machine. Okay, Anybody has any question till here? So from the assignment number 1, we have created up to point number 7. Okay, point number 8 and 9 was remaining, where we have to connect to the EC2 private EC2 machine. We have to connect to private EC2 machine, right? Now this is my private EC2 machine. Nobody from outside this is right now. I'm here. I can connect to public EC2 machine over the internet, but I can't connect private EC2 machine. Why? Because there is no internet connectivity between these two route table and internet gateway. There is no connectivity between here. Agree? So all the database, all the sensitive applications or internal application should be created in a private subnet. So no external person or entity can attack on your machine, on your application. Now, but assume that this is a database. I need to connect to this database, right? How can I push a database or data into this database? Assume that it's a RDS machine. So I need to push the data, right? So how it is done? So I told you yesterday that each subnet are able to communicate with each other through the routers. Each route tables are able to communicate with each other through routers. Internally, in a given network, each subnets can communicate with each other. That means this EC2 machine can communicate with this EC2 machine. This EC2 machine can communicate to this EC2 machine. How can we do that? I will tell you. So now what we have to do to connect to this machine? First of all, we have to connect to the machine which is in public subnet. From here, this machine will able to communicate to this machine through the route tables. So we will log in through this machine into this machine. We will log in private machine through public EC2 machine. How? So this is my public EC2 machine, right? Let's create a duplicate of this. Okay, this is my public EC2 machine. Again, this is public. I have created 2 sessions. So now here you have to create a security group. Now you have to create a security group. Our private EC2 machine was attached to default security group. Yesterday we didn't attach to main security group. We attached to private. Yesterday we created the private EC2 machine and attach it to default VPC. Default security group of our VPC. You can see here. Now I'm going to create a custom security group and attach to my private EC2 machine. So let's go here. You will find a security group. Create a security group. Select your VPC and give any name. My DB security group. Okay. Now inbound traffic, you have to select all these inbound traffics. SSH, HTTP, HTTPS, we know that. Let me add this one. Okay, this one is for database MySQL. Okay, now here I am not giving open to world. No, I don't want my security group to open to the world. Okay, and there is one more IP. It is all ICMP. This is basically to enable the ping and communicate to between the EC2 machines. Now, from which IP range I want this EC2 machine to be connected? Should it be open to the world? No, I don't want this EC2 machine to be connected apart from this IP range. That means only allow this IP ranges, right? Where this EC2 machine belongs to? Where this EC2 machine belongs to? In this subnet, I want to connect into this EC2 machine. So how it will connect? We are going to connect to this EC2 machine, public EC2 machine. From here, we are going to navigate to the private EC2 machine. For that, we are creating a security group. So in security group, we are not opening the port for all the IPs. We know that this is the only IP range through which we want to allow the connection. So why should I open for all? Rather, I will open for only IP ranges for my public EC2 machine from public subnet. So all the machines which are created here, only the machines which are created here will able to communicate to this EC2 machine. Apart from that, any other IP will be there, it will be blocked. Okay, so I have given this thing in detail here. Okay, and just save it. Now we have created a security group. All these ports you know. Now it's time to change the security group of our private EC2 machine. Go to your EC2 machine, go to action, go to security and change the security group. Okay, add the new security group which we have created, MyDB security group, and remove the previous one. Remove the default one and save. Okay. Now, okay, let me show you before updating the security group what was happening. Let me attach the previous security group, default security group only. Okay, this is my private EC2 machine, and on private EC2 machine we have default security group. Now if I try to ping this machine, ping and the private IP address. So you can see, though I am saying that this is in the same network, this machine should communicate to each other, I am not able to ping the machine. Why? Because of security group, default security group. Okay. Now if I update the security group to the which we have created, my database, and remove the default one. So we have changed the security group. Now you can see after changing the security group, we are able to ping the machine. So our public EC2 machine is able to ping the private EC2 machine. Now, can I connect to the EC2 machine? Yes. So what is the command? So for Linux, what is the command? SSH username @ IP address, and we have to pass the key. This is the syntax. So you can see here, to log into the public EC2 machine, ping the private EC2 machine, and this is a command for your to log in into the private EC2 machine from public. So to connect any EC2 machine, to connect any Linux machine, what is the command? SSH username. What is the username? EC2-user @ what is the IP? This is the IP. Okay, just try to enter this. Yes. Now you can see I'm able to ping, but it is saying access denied. Why? Because each EC2 machine required username, IP address, as well as the key, the private key which we have created. Whenever we are connecting to our EC2 machine, we required key, right? Key value pair. So what is the key we have created for use it? Uh, what is the key which we have used for creating this machine? It's my key. It's a PAM. So if you have stored that key, you have to use that key and save it into the public EC2 machine. So this is my key which I have stored, PAM, not PPK. Okay, open it into the notepad. This is my key. Now I want to copy this key in my public EC2 machine. So either you upload to the EC2 machine by connecting it, or you just create a file here. How to create a file, you know. So this is a command: create or copy PAM here using vi editor. So vi my PAM dot my key dot PAM. Okay, just insert the key here, copy the content and paste. So basically I have just copy pasted the whole key here. Okay, I have copy pasted the key. Now I will give up. Next step is to give the permission to access the key. This is a command: chmod 400. Just giving a read permission. That's it. My key is ready. So what is the command? SSH EC2 machine, EC2 user @ IP address -I and key name, my key. Now you can see I have switched to the private EC2 machine. The IP has changed. This is my public EC2 machine. From public I have jumped to the private EC2 machine. Okay, now let's try to connect to internet. Curl www.google.com. Okay, if I use the same command in public EC2 machine, see the IP, I get the response, right? I get the web response. So here in the second tab I have logged into a private EC2 machine, but here I am not able to connect to internet, right? Because private EC2 machine doesn't have internet connectivity. This is how we connect to our private EC2 machines. Okay, this is completed. Now you can try yum update as well. Sudo su yum update. What will happen? So it is not able to connect to internet, you can see. Is it clear? So in real world, this is how the private machines are preserved. So basically here it can be your database, here it can be your sensitive servers. So only these machines, the machine in the public subnets or specific number of machines are allowed to communicate with your private machines within a network. That is also within the network. Okay, so in industry, when you will work for a company, to access the public company's application, company's servers, you have to connect to the VPC, uh, basically VPN. You have to be in company's network. So when you connect to company network, you connect into their public network, and from there you are able to access their application, private applications. Okay, now any question till here? So we have connected to our private EC2 machine, we have connected to our public EC2 machine. Now the next part is man operation and maintenance of our private EC2 machines. Now let's see what. So this is a real architecture which is required. Every application will have this setup. That's it. The part number one. Now this is your EC2 machine. This is your server, right? Now your server needs to update. Then there might need to have some uh, software patching. How can we do a software patching? How can I update the version of this EC2 machine? Or let's say this is a database. Let's say this is a database. Now if this is a database and I have installed a antivirus on this machine, okay, the antivirus needs to be updated, right? Over the time this antivirus needs to be updated. Even the I need to upgrade the software of the database. If it's in private EC2 machine, if it's in a private machine, that means this machine will not able to communicate over the internet. So how can we install the patch? How can we install the upgrades of this machine? So one option is to download the software here, bring the software and copy it to this machine and install it. When you don't have internet connectivity, what do? You download the software to a machine which has internet connectivity and copy it through pen drive and transfer to the machine which doesn't have internet connectivity, and then install it. This is the one way, right? Second way is to connect a secure internet mechanism for our private EC2 machine. How? So I will just give you one pictorial diagram what we can do. So assume this is a bank, okay, and this is a safe area or secure area, right? So whenever you are in the bank, can you access the whole area? This is the main gate, let's say. This is a main gate and this is a reception area. Here are the employees sitting. So as a person, as a public person, can you access the secure area? What do you have to do? You have to go to the bank and interact to the bank people, bank manager or bank person, and if you want to submit your money or if you want to access something, so you can't access directly. You have to ask the bank employee to access the secret area, and they will come back and give you the requirement again. Right? This is what we have done right now. So, and nobody can access the secure area. Only the bank employees or authorized person can access the security area. So you have to communicate to the bank employee, and they will connect to the, or they will log into the secure area. This is what we have done till now. Okay, this is a public EC2 machine, this is a private EC2 machine. Now take another example. This is a jail, and in the left side this is the prison. Okay, here there are there is one person who is in jail, right? And there is a one security guard. Can anybody from outside world can meet this guy who is in jail? No, right? Can he go and purchase anything from outside? Let's say if he required a medicine, he's a medicine shop. Can he or she can go to outside and purchase the medicine? Yes or no? So this is a private vault, and this is a prisoner. He can't go outside and purchase the medicine. So what he will do? He will ask a person who has the internet access, who has the, from out of these two person, who has the accessibility to the medicine shop, the jailer or the security guard. This person, the prisoner, will ask the security guard to get the medicine for him. So this security guard will go out, will purchase a medicine, will come back and give the package to this person in the prison. This is how the system works, right? This person cannot go out, but this person needs has some requirements which can be fulfilled from the outside world. So this person will communicate to the security guard or the the person associated to help this prison, and that person will go outside world and get the required information. Now for medicine shop, who has purchased the medicine, prisoner or the guard? For medicine, as a medicine person, who has purchased the medicine, prisoner or the guard? Medicine, for a medicine shopkeeper, only the security guard is coming and picking up the medicines. Now assume that this medicine shopkeeper is quite aggressive, and he one day he gets angry, he beats this guy. Will it impact the prisoner? Will it impact the prisoner? So all the risk is taken by the security guard to go out to fight with medicine person, come back and give the medicine to the prisoner. All the attacks can happen on this guy because this guy is exposed over the world. So similar thing happen for your private EC2 machine and public EC2 machine. So right now, this is your private EC2 machine. This is your public EC2 machine. Public EC2 machine and private EC2 machine can communicate with each other. Your public EC2 machine can communicate from outside world, but your private EC2 machine cannot, right? So this private EC2 machine can ask your public EC2 machine to bring us some package, let's say antivirus, a new update of antivirus. So your private EC2, public EC2 machine will go to the internet, will download the package, will go to the server, will download the package in this local system, and then it will be transferred to the private EC2 machine. Okay, this is a temporary download. Okay, so your private EC2 machine are still secure, but they are accessing the internet through a machine which is in public subnet. Okay, they are not going outside. Nobody knows that there is some private EC2 machine. All they know is there is some machine which is required some package. So if any cyber attack happens, only this machine will go down. Still your private EC2 machines will be secure, or your database will be secure. This is how the concept called proxy works. You might have seen you might have heard proxy. So basically proxy means in school or college you might have given a proxy for your teammates or your classmate. What is my proxy? Not the actual person. The other person will act in place of that person. Right? You apply a proxy for the other person. So that is what here is happening. This is private EC2 machine. They are not going outside the world. They are asking a other person to act like him and go outside the world, bring the required software patches, upgrades, and provide to the private EC2 machine. This is called proxy concept. Okay, same goes with our here. So now you can see here, this is my private EC2 machine. We are going to create another EC2 machine called NAT instance. Okay, which will be in public subnet, and all the requests for internet from this machine will go to the NAT instance, and it will go outside, will get the required package and return back to the private EC2 machine. So we are still nobody will able to connect into the private EC2 machine. Okay, for outside world only this machine is getting exposed. So if there is any risk, only this machine will be taking the risk. We are providing a pathway or provisioning internet facility to our private EC2 machine, so that the request can be initiated from inside, not outside. The request will be initiated from inside, not outside. Nobody will communicate from outside world. Only there is a, if there is a upgradation, software patches, all the requests will initiate from the machine. Now previously Amazon was having a EC2 machine called NAT machines. It was having an AMI which is designed specially for acting as a proxy servers. Okay, and they are called NAT instance. But Amazon has terminate or decommission this service. Why? Because users has to maintain this machine. Okay, we have to maintain this machine. If this machine goes down, let's say there are multiple EC2 machine in private, there are hundreds of machine. Okay, just like here, let's say there is only one prisoner and one security guard, then the request is able to handle. But if there are hundreds person here, 100 prisoner, and all of them are asking request or favor from security guard, what will happen? The security guard will be overhead, and if the security guard take leaves, what will happen to these people? They will not able to communicate over the world. So what you do? You create you have multiple security guard then. which will able to handle this privileged request. So if you are handling multiple security guard, you have to pay, you have to maintain them. Same thing goes with NAT instance. These are the EC2 machine which you have to maintain. And if this NAT instance goes down, the internet to this machine will be hampering. So for that, Amazon has created another service called NAT Gateway. It is similar to NAT instance, but here this is a gateway. Just like internet gateway, it is managed by Amazon. Amazon says that the gateway will never going to be down. It's always up and running. So you don't have to maintain this machine. It has service. Just use this service and attach to your private subnet. That's it. How this machine are providing internet, how they're acting as a proxy, you don't have to worry about it. Just attach an ad gateway. So let's go to console. I will show you how we can do that. So this is my public EC2 machine. This is my private EC2 machine. You can see right now connection timeout happen. We are trying to update the software. Okay, we were trying to hit the website, Google website. Nothing is happening. Okay. Now I need to provide internet to my private EC2 machine. Okay. Let's go to, let me check if they have NAT instance are available. Otherwise, we will create a NAT gateway. So go to the assignment number 2. The first part is NAT instance. Instance means EC2 machine. This is the first part. But this is decommissioned by Amazon. But let's see if they have the AMI available. Okay, they have stopped publishing the AMI as well. These are the special machine created for NAT instance. Nope. In the community, NAT hyphen HVM. Nope. So they have decommissioned the instance as well. Let's check out this one if this can be used. I'm not sure it will be helping, but still, it is a net VPC net. Okay, just select this one. So this is a special AMI, net AMI. Let's check if it is supported by T2 Micro. Yes, it is supported by T2 Micro. Okay, you can give the secure key value pair. But now, which security group you have to attach it? Which VPC? Our VPC, and which subnet? Private or public? This machine should be in public. Always remember, the NAT instance and NAT gateway should be in public. Okay, security group. Attach the security group which we have created for our VPC, public EC2 machine. It should be having HTTP and HTTPS also. S protocol should be enabled. Port 443. HTTPS protocol should be enabled. And just launch. Okay. We have launched the machine. Now these are the few settings which you have to do. You have to disable source and destination check on this machine. Okay, so just give a name, NAT instance. Okay, there are some settings which to make this machine as a proxy server. So inside your machine, go to the network and settings and change the source destination. So select this instance, go to action, go to networking, and here change the source destination check. You have to stop it. Okay, disable it. That's it. Right? Now this machine is ready to act as a proxy server. Okay, but how can our private EC2 machine will able to communicate to internet? What is the path? This is the path. This is a route table basically, right? So route table only everything works. So I have to attach this NAT instance or NAT gateway basically to our main route table. So this is my main route table. Go to your main route table. Uh, Go to your VPC. Go to the route table of your VPC. This is the main route table of my VPC. This is my VPC and this is the main route table, and all the private subnets will be attached to the main route table. Okay, you can see this is attached to the main route table. This is private. Go to routes. Go to edits. Okay, now this private need internet access, so open to all the secure IPs and instance, right? Instance, here you will find all the EC2 machines. Give net instance. That's it. So you have saved, you have created. Now let's check the connection. Now you can see this is my private EC2 machine. It is able to connect over the internet. It is only one-way connection. From inside you can do. So yum update. So you can see it has trying to communicate to the Amazon EC2 repository. Okay, if you want to download anything, you can do that. So our private EC2 machine is able to communicate over internet through net instance. Now problem with net instance is if this machine goes down, whole your application will lose the internet connectivity. So let me terminate this net instance. What will happen if I terminate this machine? So if you refresh here, right now your net instance is active. After some time it will show deactive, black hole. So basically it depends on the single machine, single point of failure. So if that machine goes down, all the internet connectivity to your private EC2 machine will go down. You can see again there is no internet connectivity to your private EC2 machines. So that's why Amazon came up with a new service called NAT Gateway. What is NAT Gateway? It is again a managed service by Amazon. It's a group of NAT instance managed by Amazon. So there are hundreds of NAT instance working behind, and they will provide you the internet connectivity to your private subnet. Okay, simple. Go to here, go to the NAT gateway, but remember NAT gateway is a very expensive service. NAT gateway. Give name my NAT gateway. Okay, in which subnet should be this NAT gateway, public or private? Always remember it should be in public. NAT gateway or NAT instance should be in public subnet. Okay, connect to the public. Now you have to allocate an IP address, elastic IP address. It required elastic IP address and save. So NAT gateway is ready, it will take time to this NAT gateway to be coming up. It will take time to provision this NAT gateway. Meanwhile, in the route table, you have to change the routing again. Now, instead of this is my main route table, this is my VPC. Now, instead of this EC2 machine, I need NAT gateway. Okay, if this gateway provisions, if this gateway is up, then you will get the internet. Okay. Meanwhile, I will show you the charges of NAT gateway. It's a chargeable service. It doesn't come in free tier, so use it wisely. So there is no charge for VPC. There is no charge as such for VPC, but for this NAT gateway, there is a charge. You can see per hour there is a $0.045, and as well as per GB data download from the internet. This is the charges for NAT instance or NAT gateway. It is hourly service as well as the amount of data you are downloading from internet. It will charge you for that. Okay, so hourly service and data charges. So status is available. Let's go and check if it has given the internet access to my private EC2 machine. You can see my private EC2 machine is able to communicate over the internet. Now this is a chargeable service. If you forget to delete this, you will be getting charged. So the first thing I always do is to delete the NAT gateway. It is a very heavy charge service. Okay, after deleting this, it has created a IP, Elastic IP. You can see. So release the IP. Okay, after the NAT gateway is deleted, release this. Release means return to Amazon. Okay, so let's go and check the theory part. So till now what we have learned, when you create a VPC, a default route table and NACL, network access control list, and default security group are created. It won't create any subnet, nor it will create a default internet gateway. US each one in your account can be completely different ability zone in US each one in another account. Ages are random. So what is this point? Basically, this is 3 ability zone. In my account, Amazon will, this is ability zone A, B, C. In my account, this is showing. Okay, let's say this is Mumbai, this is Delhi, this is Pune. Okay, but in your account, Amazon might give this as a, this as a B, or this as a C. Okay, Amazon randomize the ability zone in different account. Why? Because most of the people are using A as a default one. To make it more random and more distributed, Amazon will change the ability zone in different accounts. So my ability zone A will be Delhi, but for you it can be Mumbai. Always Amazon always reserve 5 IP addresses within your subnet. You can only have one internet gateway per VPC. Security group cannot be outside VPC. You have to create a security group within the VPC. These are the URL for NAT instance. You can check it out. When create a NAT instance, we have to disable the security and destination check. This is to enable the proxy server. NAT instance must be in public subnet. This is important. there must be route out to private subnet to net instance for this to work. So we have to attach a net instance to the routers. The amount of traffic that net instance can support depending on the instance size. It is a EC2 machine. It's a proxy server. If you are bottlenecking, increase the size. You are you can create high availability using auto scaling group, multiple subnet in different availability zone, and set up a automatic failover. So we have seen this. So if you are creating net instance, if you are still using net instance, create a auto scaling. So automatically create the net instance using auto scaling. So if net instance can go down, it will create another one. Create two net instance instead of one. Your EC2 machines are always behind a security group. Even net instance is a EC2 machine, right? So it will be behind the security group. Net gateway. Now what is net gateway? Redundant inside the availability zone, preferred by the enterprise. It has a high internet bandwidth. It can go from 5 GB Gbps up to 45 gigabytes per second. No patch required. So in that instance, what is the drawback? You have to maintain these servers, maintain this EC2 machine. You have to upgrade. You have to enable the patches. But in NAT gateway, everything is managed by Amazon. You just has to attach it, just like internet gateway. No associated of security group. No public IP required. It automatically assign the public IP. Remember to update the route tables. You don't have to make it proxy server. You just have to attach. Okay. You can create multiple NAT gateway in different availability zone and attach to your VPC. Okay. I'm releasing the IP Elastic IP which is created by NAT gateway. So NAT gateway is deleted. Any question here? Till here? Then I will go to the NACL. So this is our network right now. This is our network right now. We have completed assignment number 2 till here. I just want to cover assignment number 3. It will take 15-20 minutes. Are we clear? Now, this is my infra right now. This is my infra right now. Okay. Now, what is security group basically? What is security group? It is a security group is a template. It is a policy template which allow specific type of traffic from a given IP range to my EC2 machine. Right? Security group are attached to EC2 machines. It only allow a specific type of traffic to my EC2 machine from a given IP ranges. Right? But I don't want my traffic to be coming in the network itself. If I want to block something, if I want to restrict the traffic on network level, not on machine level, security group are used to restrict the traffic on machine level. That is a EC2 machine level, instance level. But I want to restrict the traffic. Okay, I want to create a policy which can be act on a network level, VPC level basically. I want to control which type of traffic should be coming to my network. Basically, if you consider in your country, what type of people are coming to your country, okay, how they are coming, it is controlled by our government. At your home, you are the owner, you can control, but at the country level, how can I restrict? So there are some policies, government has laid down some policies. After a person has entered the country, then only he or she can come to your home, to this EC2 machine. A terrorist can come to your home only if your government allow. But if a government is blocking the terrorist on the country level, will that be attacked on your EC2 on your house? Similarly, if I want to block or restrict the traffic on a network level, so that that traffic will not come to EC2 machine altogether, you don't require security. Uh, you don't have to additionally add a security group for that. That's why NACL comes in picture. Network access control list. Network access control list is basically is a superset of security group. Okay, it's a superset of security group where you can restrict the traffic coming in your network. In your network. So network level security, if you want to enable, you have to enable access control list. So in this there is a inbound, again just like in security group there is a inbound traffic, there is a outbound traffic. Inbound traffic and outbound traffic. So traffic coming to your network, traffic leaving out of your network, both is controlled by NACL. Okay. So before going to NACL, just I will cover few properties. So NACL, your VPC automatically comes with the default NACL, and by default it is allow all inbound and outbound traffic. Okay, so let's go in console and create a NACL. So you can see, continue from the assignment, create an NACL. Now there is one interesting thing about NACL is you can block the traffic using NACL. Can we block the traffic using security group? We cannot block any traffic using security group. You can only enable the traffic. If I want to block a single IP address, okay, let's say this is a server which is trying to hamper my application, and this is, let's say IP is 192 dot something something 1.1.1. okay, in security group I don't have provision to block a IP address. It only allow the IP address. Okay, in security group we cannot block the IP address, but through NACL you can block the IP address. Second thing, in security group if you allow the inbound traffic, automatically outbound traffic is allowed. So let's say you have opened a port SSH, you have enabled port SSH as a inbound traffic, so outbound traffic is automatically allowing SSH. If you have enabled HTTP protocol, so for inbound, so outbound will also allow HTTP automatically. But in NACL you have to specifically allow an inbound and outbound traffic. We'll see that. Okay, you have to, there are two different tables and both should be allowed. Okay, now this is my public EC2 machine. We are in public EC2 machine right now. Let's create a website, host a website here. So I have pasted the bootstrap script. So now the website is start. So I just have to grab the public IP address and paste it into the URL. So you can see the website is running. On which protocol I'm connecting to this website? On HTTP protocol. Right? Now let's go to VPC. Let's go to NACL. Now if you see here, this is my NACL which is created by us in our VPC. For our VPC, a NACL is created, Network Access Control List. This is a default NACL, you can see. Here, now you will see all traffic is allowed. And outbound, all traffic is allowed. And similar to route table, each subnet should be attached to one NACL. Okay, each subnet should be attached to one NACL. So in the diagram, if you see, this subnet is attached to default NACL, again main NACL. So this is a default NACL. Now we are creating our new NACL. Give a name, Network Access Control List. And attach to your VPC. So this is my NACL. Now if you have created a new NACL similar to security group, there will be all traffic will be blocked. All traffic will be blocked by default. So inbound traffic is blocked and outbound traffic is blocked. You have to explicitly add the inbound and outbound traffic. So which traffic I'm adding? Okay, we have hosted the website on EC2 machine. Now it is saying associate our public subnet to this NACL. So go to the associate. This is my NACL, custom NACL, associate a security group subnet. There is no subnet here. Click on associate subnet and I'm attaching a public subnet to this custom NACL. So basically it's a security. Okay, I have attached the our public subnet to this custom NACL. So this is a diagram right now. So this is a diagram. Not this one again. So your VPC looks something like this. So there is a custom NACL we have created for our public EC2 machine. And this is a default NACL attached to our previous subnet. Now let's refresh the website once. Now you can see the website is not working. Why? Because we didn't allow inbound and outbound traffic. Because your traffic is going from internet to route table to this NACL. We didn't configure this NACL. Right? So as per your assignment, inbound traffic, you have to open the ports. Which protocol we are working right now? Protocol 80, HTTP. So I'm opening this ports in our NACL. This is my NACL. Go to inbound traffic and add. Okay, SSH, HTTP. Let me add HTTP, HTTPS, and SSH. Okay, okay, 100. 200. Here you have to give a number. What is the rule number? I will explain you in some time. Everything is allowed. Just save it. So I have enabled the inbound traffic. That means the traffic from outside world will be able to communicate to the EC2 machine. That means this website should work. Again, it's not working. Why? So I can communicate from outside world. I can send a signal from outside world, but response is not coming. हम लोग पत्थर फेंक सकते हैं पर वापस नहीं आ रहा है. Okay, we have enabled only inbound traffic. We can send the signal inside. We cannot bring the signal outside. Response is not there, right? So we have to enable the outbound as well. You can see outbound is denied. So nothing will come outside this security group. Go to edit. To enable this thing, you have to enable all these ports. Okay. So let me add 3 ports which are default: HTTP, HTTPS, and SSH. These are default ports which we are adding. Apart from that, these are the custom ports which needs to be added in outbound traffic. Okay, custom ports for outbound traffic. Give a number 100, 200, 300, and 400. That's it. Now, as soon as the outbound is enabled, refresh it. Now you can see the website is working. Right? So in NACL, you have to explicitly allow inbound and outbound traffic. In NACL, you have to explicitly allow inbound and outbound traffic. So if you allow the outbound, then only the traffic will work. Okay. Now what's the benefit of NACL? NACL is working on a network level. Security group works on a EC2 machine level or instance level. It's a very common interview question. Okay, difference between NACL and security group. So I have given a PPT. There is a PPT difference between NACL and security group. It's a very common interview and exam question. What is the difference between NACL and security group? So NACL works on a network level. Security group work on a EC2 machine level or instance level. Second, if you allow inbound traffic in security group, it will automatically enable the outbound traffic. So there is a PPT. We will cover that. Okay. So this is a PPT describing all the features of NACL and security group. But before that, let's cover one more thing. Can I block the IP address from security group? No, I cannot block any IP address using security group. If you go to security group here, if I create a new security group, it only allow the inbound traffic. It doesn't allow any blockage. Okay, you have to just add which traffic you want to allow. But if you go to NACL, custom NACL, if you go to inbound traffic and edit, you can see allow or deny. So if I want to block my IP address on port HTTP, okay, so what is my IP address? My IP, I want to block my IP address. So this is right now my IP address /32. I want to block my IP address. Save. Okay. Now if I refresh, okay, I'm able to communicate to this machine. Still, I have blocked my IP. still I am able to connect to the EC2 machine. You can see I have blocked. Okay, so why this is still allowing? Okay, why this is still allowing? Because of this number rule. What is the number rule now? Now you can see HTTP protocol has two values. Okay, HTTP has two values. One is 100, other is 400. So how NACL work? It gives a ranking to the order. So out of these two, which has lower rank, okay, will be acting first. Okay, so because of this, for 100, because of 100 HTTP and 400 HTTP, there are two rules. Out of these two rules, first this will be evaluated, and this says that it is allow. First rule says allow. So that's why I am able to communicate to this machine to make it. If I want this to evaluate first, make it in a low priority, uh, low ranking. So now you can see 99 and 100. These are the two HTTP protocol. Out of this, which we evaluated first, which has lower number. This will be evaluated first, and it says deny this IP. Okay, save. Okay, it has saved. Just now check, refresh it again. Now it is blocked. So I can block my IP address using NACL. I can block the traffic using NACL. So this is all about that. Okay. Now let's go to the PPT. So your VPC automatically comes with a default NACL. By default, it allow all inbound traffic and outbound traffic. Default NACL. You can create custom NACL. By default, each custom NACL deny inbound and outbound traffic until you add a rule. Each subnet in your VPC must be associated with a NACL. Every subnet should be attached to NACL. जो भी subnet आप create कर रहे हो सब NACL से connect होने चाहिए. If you don't explicitly associate a subnet with NACL, the subnet will be automatically associated with the default NACL. If you are not attaching a subnet, if you are creating a subnet and if you are not attaching a NACL, by default it will connect to default NACL. If you are not allowing any, अगर आपने एक सबनेट बनाया है और आप उसको किसी भी NACL से अटैच नहीं कर रहे तो कहाँ पे अटैच होगा वो? डिफॉल्ट NACL से. If you want to block an IP, use NACL, not security group. You can associate a network ACL or NACL with multiple subnet. एक NACL multiple subnet से attach हो सकता है. But however, a single subnet can be attached to only one NACL. एक subnet, एक NACL. Just like your passport. You can have only Indian passport or you can have only one citizenship. Okay, country can give many citizenship to many people, but a person can only have one citizenship in India. When you associate a NACL with a subnet, the previous association remove. मतलब अगर आपने change किया सब NACL तो वो पहले वाला हट जाएगा. NACL contain a number list rule that is evaluated in a order starting with the lowest number rule. NACL has a separate inbound and outbound rule. Each rule can be either allow or deny. NACL is stateless. That means response to allow inbound traffic are subjective to outbound traffic. So basically NACL को stateless कहते हैं और security group को stateful कहते हैं. ठीक है, स्टेटलेस क्यों कहते हैं? क्योंकि इनबाउंड ट्रैफिक आपको अलग से डालना पड़ता है, आउटबाउंड ट्रैफिक अलग से आपको अलाउ करना पड़ता है। अगर आप दोनों को नहीं करते तो आपका ट्रैफिक ब्लॉक रहेगा, राइट। बट सिक्योरिटी ग्रुप में क्या है, अगर आपने इनबाउंड अलाउ कर दिया तो आपको आउटबाउंड अलाउ करने की जरूरत नहीं, ऑटोमेटिकली अलाउ हो जाता है। ओके, सो दैट्स अ सिक्योरिटी ग्रुप। तो इसको बोलते हैं स्टेटफुल। सिक्योरिटी ग्रुप आर स्टेटफुल। दिस इज अगेन इंटरव्यू क्वेश्चन। स्टेटफुल and secure NACL are stateless. This is the difference between NACL and security group, a very common exam and interview question. Okay, now right now this is our network. We have created subnet, we have created EC2 machines in private and public subnet, we have created net gateway, we have created custom route table as well custom NACL. Okay, so I'm stopping here. If you have any question, let me know.